Hello there, everybody. Okay, so that was the new intro that I'm trying out. Hopefully, I'll be able to look back at the stream and see if it worked or not. But for now, let's get started on the game that we're playing today. And that is the Human Resource Machine, Part 3 or Part 4. I can't remember, but essentially, we are on the last two levels of the game. So, let's see if we can try to solve them today within the next hour or so. As you can see, our guy is pretty old. He is pretty much essentially in his prime. Hahaha. Prime, get it? But yeah. So last stream I think I did like level 30 to 39. I remember some of these were pretty bad because I literally got no achievements. But we got through them. That's something, right? Also, Phenotype, how are you doing today? Our goal is literally just to try these two levels. I heard these two levels are pretty hard, and these are probably gonna take me an hour anyways, so it gives me a chance to try new stream stuff that I've been working on in the background. Let's check it out. Prime factors. Year 40. Look how old I am, by the way. Like, I have like almost no hair left, and the building's almost dead. Are you sure you're supposed to be here? This is a very difficult assignment. I have no idea how to do it either. And look, the scientists are back. Let's see. For each string in the box, send its prime number factors to the outbox in the order for each thing in the inbox, send its prime factors to the outbox in order from smallest to largest. Wait a minute. Aren't primes essentially a number multiplied by itself? So literally the answer would just be like 1 and 17, 1 and 15, 1 and 11, right? No more interviews this week? Nice. How'd your other interviews go though? Oh. Your inbox is 12. 7. The outbox should be 2, 2, 3, 7. Okay. So in this situation, it would be 3, 5, 11, 17. I'm assuming. That's gonna be a tough thing to figure out. They were okay. I have one offer coming out at the end of this week earlier. Oh, that's awesome. Congratulations. I know you worked really hard for it, so that's awesome to hear. Yeah. That's good to know. At least now you don't have to worry about getting a job anymore, and hopefully you get started next year. That'll be fun. You gotta make money, which then you can donate back to me, obviously, because I'm your favorite streamer of all time. Hands down, right? Okay. Let's see. What is the strategy that we are going for today? Let me check. Let me try something first. Window capture. Oh, not this window. Not those windows. Okay, never mind. I should not show that yet. So it's not a Windows capture. Remove. Let's see. What if it's a... No, that's not a display capture, I don't think. Huh. Video capture. Let's try that first. double the game. I probably should have tested this out off stream, low key. But it's fine. Oh, did something happen? Did I actually make some odd noises? Uh-oh. What happened? Note to self, don't open up stuff on off stream. Okay, I guess I'll work on that another time then. Because I actually have like a painting thing that I wanted to open up so I can like start drawing out my ideas. But yeah, I probably should have tested that beforehand. It's okay though, I'll figure it out. Anyway, let's get back to this problem. The question is, do we know how many items are going to be coming from this box? Can we assume there are like 3 or less? That's what I want to know. And it doesn't have any like index functions. So that means we can't do any indexing on these things either, which is gonna suck. Huh. How would we solve this? Let me test to see if this sounds really bad right now, but what I want to do, maybe copy input. How would we do this? Prime factors. This actually is pretty tough. I don't have like an idea currently. Because like you would need the numbers from 1 to however many this number is, right? How do you tell the number is prime like instantly? And how do we know how much what the range is? Use 28 or fewer commands. Use 399 steps. Okay. So let's say we input it. Let's say we add it to... Oh, never mind. There is indexing. I'm wrong. Copy to... Bump. This number. I guess I'm a bit rusty in this game. Actually, let me try to go back and see what the other question is, because maybe my brain can work in the background. Otherwise, I have no clue currently how I would do something like that. When I went to switch the screen game audio, the audio went super loud. Yeah, that's... I think I understand why. When you open up like 2 games, every sound is like duplicated. So they probably like exponentially made the sound louder, which is not good. So yeah, I apologize for that. I won't do that again. Let me check this out, this new office. Be ready, climb the corporate ladder together. Thank you, my surviving skills are really adequate. Those are pretty good too. Whatever it is you do over there, so are you ready? What the? Did I do this? I don't think I did this. For each 0, terminate a string in the inbox. Sort the content of the string, smallest first, biggest last, and then put the results in the outbox. Repeat for each string. So, let's say we have these 3. Copy from, copy to. $20. Okay, so we're saying put this here. Inbox. Copy to wherever 20 is located. Jump to, if 0. Bump 20. Get more inbox. If 0, go to the end. Oh, okay, so essentially the code is just says essentially go from there to there, and now they want you to sort it after that. So this part already apparently solved how we're going to get all these letters into these grids. Now the question is, how do we know how to sort them? And how long are the letters? See, like, that's a really long string of numbers right there. How would we ever know how long something is? Can we assume like half the board will be the length and the other half is for sorting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So essentially the count, the bump will be telling you how many numbers there are. And so I'm just going to assume that the first half will be for the letters and the second half will be for the sorting. Okay, so let's do that. We already have all the inbox things set. Now we need to compare between the items. My idea is to have a counter system right here, where one of them's index. Let me just write that in. Counter. Counter. So what this does is that it will look between the options. Let's say I start with box 0. I'll check with 1. Is this number less than or greater than? Then check with 2. Then check with 3. Then check with 4. And it will count how many times it is less than or greater than. And then it'll place it based on the position of, you know, how many times it's greater than less than the numbers here. That's what I'm thinking. I think that's a good start, which means this is first the index. This is the 0 spot. So let's say 98, 38, 92, 0. This is 3. This is that. Copy from. Whatever the index of 21 is, but also at the same time, let's have a copy from, copy to this right here. So this would be my second counter. This one would count the position. So essentially it's another index, essentially. I can't even write with the sign. Position. Make sure I also got a copy to counter. Copy from position. Let's say we go to bump this position. Okay. So what I want to do is first get the first index, which is what this was. Then I want to bump the position, but then that's going to kick the box out of the way. That's what I don't like about this. Because what it does is that once I click bump, this will move up one. But then he's going to throw that box away. Unless I start with everything else instead. So let's go to position 2. So, like, let's get rid of this copy from. And let's put copy from afterwards. So I'm essentially saying, let's pick up this box and then compare with the 0 position. Next box, compare with the 0 position. Next box, compare with the 0 position. And I'll just add up the counter. And when the counter is done, I'll move this box instead. Okay, I think that'll work. I think that strategy might work. So copy from, subtract from. This is definitely going to be a pain. Do I need a third position box? Is that really what I'm doing? I guess I'm making a third position box. Oh, that's not good. That's not good at all. Yeah, I might as well do the third position box. Just in case. Let's see. Bump the position. Copy from position. Subtract from whatever 22 is, aka indicating 0 position. If negative. If negative, which means that number is less than 0. Then we just move on. But if it's positive, it means that that number is bigger than that number. Which then we just... let's say we add counter to that bump. Let's bump the counter position. So now we're saying there's one bit number greater than this index position. I'm trying to do this in my head. It's actually kind of hard. I wanted to like have a drawing tab on the side, which is what I was trying to do, but that's not gonna work. Let's do it in our heads, because we're geniuses, right? Let's do it. So once we have the counter, we don't really care about the item we're holding, so that doesn't matter. So once we bump that, let's bump up position, and then we bump, and then we'd restart, right? I don't know why I put copy to 0 there, but okay, copy 22. Bump up the position. Oh wait, that's what I did right there, huh? Let's test this out. I actually want to see if it works first. So the first part, just adding the numbers. Let's add the zeros there. Nice. Okay, take that. Subtract that. It's a negative number. So obviously it's not going to add. Right? Oh crap. I should have stopped. I clicked pause instead of stop. Okay. So 71 is the biggest number. Obviously. Which means that they obviously had no counter. So, based on that information, we should put it in the third position from the 0 index area. That works, right? I think. But we gotta make sure at the 0 mark. Copy from position. Jump if 0. And then we'll go do something else. Inbox minus counter. I think that's what I want to do. Inbox. Subtract the counter. So that'll give me a 3. But what I want to do is I want to add the 9 to the 3. How would I do that? Because I only have these spaces to work with. Unless I'm supposed to get rid of the inbox area. I don't think I want to get rid of the inbox area. Can I get rid of the position? I think I can. Yeah, let's put it to position. Copy to position. And then we'll bump the position 9 times. This is such a pain. This is not correct, but this is my hard code way of doing it. I want to get a solution first. That's essentially my strategy. Get a solution first, and then we'll look about optimizing it afterwards. Because I don't know how I don't want to have an assumptions of certain things. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So based on this, This is the new index of this item. Dump 9 and then copy from this. Copy to whatever the index position of this is. And let's play this out. So the strategy is, if it works, this 85 should go in box 12. If this is done correctly. Huh. Wait. 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 That worked. That worked. It went to box 12, just like I predicted. Yo, okay, that works. Okay, so once we get that, we need to actually bump up the number of this so that now the counter is 1. And then we try it again. Right, then we copy from 0. I don't want it to copy again from the 0, so that's what I'm going to do here. Copy from 0, copy position, copy the yada yada yada. Bump position. Let's try this out. I think it should at least give us 2 numbers, right? Okay, so there's a counter 1, which means that... Wait. Let's start back at when he added this block to there, right? Bump 1. Start from the beginning. Reset. Reset. Converter. Bump position 1, which means that's a 1. Copy from that. If it's not 0, you subtract it from index of 2. Bump. Why did a bump counter when it's not negative? Oh, it's because it's not negative. I see. So if it's a positive number or a 0, then it'll just go to that counter. Which makes sense. But I should really start from 0. If that's the case. Let's not bump the position here. Let's bump the position probably right there. And then if it's 0, we just take 1 position out. This should still give us the output that I think we're gonna go through. Wait. Uh-oh. So the counter was a 1. Subtract 2. Oh, so I have to bump 2 instead of subtract 2. I think I see. It should have been adding a bump position here instead of subtracting. You can see it. It's kind of funny. Look at that. Look at that. Look at that. Oh, and then they add the 0, which is funny. Which is really, really funny. But look at that. That actually worked. Somehow, we got it to organize and order. Now, we just got to make sure that if the number is 0, we just output the box from 10 and onwards. Right? Okay. So, copy from 0, copy to, copy from position. Jump if 0. Okay, so when we had the 4th box, when was that? Copy from, copy to, bump 22. Let's click that box first so that we know where it jumps. So it jumps to here. Copy from 0, copy to position, copy to counter. Yada, yada, yada. Copy from position. Jump if 0. Copy from inbox. Okay, let me look through this code because it's kind of tedious to look through that code manually. I just kind of like the part. There it is. All right. What in the world are you looking at? So this is also hello, first of all. How are you doing? So this is a game essentially that's disguised as coding. But you're essentially trying to do certain stuff that they ask and then have it stuff inputting and stuff outputting. So essentially it's a coding game, but it's a drag and drop coding game. And I'm just trying to figure out, essentially debugging my code, try to see how I can fix this error that I'm having currently. Huh. Copy from position, which is 0. Okay. I think I should have a thing here that after I bump 22, where's bump 22? Here it is, bump 22. Let's first subtract this with this. If 0, you escape the loop. Position should still be a number. Let's bump position. And then let's copy from wherever the counter says, or whatever number 2 and 2 is. And then we put it in the bump position. So copy to bump position. This is very confusing, and don't worry about it. What is the goal here? Our goal is to have an inbox of numbers or whatever stuff. It ends in a 0, and then you go try to sort that number. So let's say 3049, and then a number here. I don't know what that number is. My screen's kind of blocking it, but you're essentially sorting the list. So A, and then H, and then MN, and then these lists of 10 numbers. You're trying to sort that number and stuff like that. So your goal is essentially just sorting the list. The question is, you don't know how long the list is, or what kind of stuff is in it. You just gotta figure all that part out, which is kind of cool in my opinion. Which is why I like playing this game, but it definitely is not very friendly to watch. I don't think. It's not a hobby that most people enjoy, I would say, but I kind of want to throw my towel into the ring, trying to see if I can do it. Copy to position. So if I play this correctly, the number should go to the list, and then it does its magic of sorting. And it will put the number in the 3rd position. The 13 should go here. And then the 41 should go here, and then the 0 should go there. What? Not enough outboxes. Oh, crap. Oh no. Okay. So the thing is, we don't know what position the ending number is. Oh, I see. Oh, that's a pain. Oh no. Okay. Let's bump the inbox. I'm gonna bump the inbox 10 times. So what bump does is essentially adding 1 to the number. And that's just gonna tell me to go from whatever number this is, let's say it's 3, to 10 of that, so that's 13. That's where I want it to be at the end. So I gotta add 10 of these bumps. There's no way to add 10 in this, sadly. I gotta manually figure that part out. It just sounds hard on paper. It is hard, and it's very hard to do it like mentally. I think most people have like a piece of paper that they write these stuff down, but I'm just doing it on the fly just because it's more fun that way, I think. Copy to whatever the position of this thing says it is. So the bracket means that it is looking for the location that is pointing to. For example, if this thing says 7, you're looking at the position number 7, essentially. So I'm telling you to have, let's say 3, add 10. So add whatever number from this box is, go to here. And then let's say you subtract from, let's say you copy from inbox, you subtract from, I think 22 was my position locating spot, and then you copy to that. So essentially I am now removing back here. So once I'm back here, outbox, copy from whatever the location of this box is, outbox that, and then you gotta bump this part, And then you loop that back. If it's 0, then we're done. And we can go all the way back to the beginning. Okay. That was a lot of chaotic mess, and like I said, it's really hard to visualize. So I'm just gonna let it run. Just do its magic. And then I'll pause it and I'll explain what I did, essentially, right there. Okay. So that number originally was 3. What I'm doing is I'm adding 10, so it becomes a 13. Which means that I grab this box and put it at 13 position. So now everything here is sorted. Oh. Actually, no, it's 0. Okay, I'm good. Then, what this does is that it subtracts this number to go back to 10. And it does this magic by putting it back here. Now I just copy from index, which is the number 10. So that's the 10 spot. And that's this number. You grab it. And you put in the outbox. And then you add 1. So that becomes an 11. You grab the 11th position. And then you go and outbox it. And if it's 0, you start over. And by starting over, I should have told it to start from the actual beginning, which is this whole thing. There we go. So with that, I think now I can solve every letter from the position index. And that is 0, nice. And then you just add the box in order. And then reset the new letters. So the A is the first letter in the alphabet, so it goes in the first position. That's always fun. The L should be the 4th, yeah. The I should be the 3rd. It's always fun to watch. I think that's the best part of coding, at least in this game. You can watch your code run, watch your guy move, stuff like that. It's always nice. And the longest part, I guess, now is just waiting to see the code works. Yeah, I think the biggest struggle I have is the fact that I don't have space for 10 letters. This is gonna break my code for sure. Oh, I think this 100% gonna break my code, because the moment it gets to that 10, it's gonna replace the the 0 position of 10. Oh, that's gonna... I don't have space for that. It's never gonna end. This code's never gonna end. You can't sub between one letter and one number. It's impossible. Yeah. Okay. What happened? Okay, I bumped that position. 13. Okay, I think I see what's happening. Yeah, I need to find a way to cut out the 0 at the end. But at the same time, I need that 0 to tell that, oh, this is the end of the number. Otherwise, how would it know when the letter ends? another way that is super, super tedious is we could do a sorting algorithm. Is there a way to clear the board? No, there is not, sadly. These are the only functions that we have. Inbox, take stuff in. Outbox, put stuff out. Copy from a position in the board. Copy to a position in the board. Add 2 numbers, subtract 2 numbers. Bump, which means add 1 or minus 1. And then jump is just like moving stuff around if it's just a regular 0 or negative. Okay, so this is gonna be a pain. And this is gonna be really sad because this is such nice code. But I think this is not gonna work because of the reason that there might be more than 10 letters at once. And we don't have 10 positions available for us to dabble with. So let's change our strategy and go for a sorting algorithm instead. And the easiest one to produce by far is the bubble sort. This is going to be a pain to erase. All that work turns to nothing. But I think we have to do it a way that it would make sense. So bubble sort is essentially comparing 2 numbers and then swapping them if one number is bigger than the other. Which definitely has a lot less space, but it takes a long time to run. What's stopping you from putting in the outbox as soon as you place them in the position? There's nothing really that's stopping me. It's just the fact that let's say the smallest number is 9. But then like I have to go through all that number first. And then once I reach 9, then I can put that 9 in. Before I can put anything else in, I had to put that the smallest number in first. So if it's somehow the last number in the list, I'm kind of screwed. Which is what sucks about the 10 number situation, but you know. It is what it is. Okay, jump. Inbox. I think initially they had a copy 0. But I'm going to leave that out for now. So I want to inbox. I want to copy it. Yeah, copy from 0. Copy to inbox. You want to copy to position of 0. And then you want to bump 0. And then you want to repeat that. Inbox. Copy to inbox. Jump. If 0. Let's get that out of there. If it's 0, then we bump it anyways. Do we bump it anyways? Yeah, let's bump it anyways. Okay, so this whole chaotic mess will just put the numbers in and tell me an index position of 3. Let's have another box copy to position. And let's do a let's see, how do I want to do this? Copy. I got to copy from 0 first, by the way. So this would be my max number. Max. And then I also get a index position. Actually, counter would have been okay, but let's call it something. Let's call it I. Because when you do coding in C++, you do I++. So that's I call that an I. Yeah, you can write on the labels. It's kind of cool. So you can somewhat track what you're doing. Let's take the first inbox. Actually, first copy to ITT. I'm just gonna leave these here for now. Let's say copy from of ITT. Let's copy it to these two positions. Or let's say 1819. Oh, I can't even say 1819 like right off the bat. Huh. That's annoying. Bump. Max. Oh. Okay, so instead of max, let's say this is JTT. JTT, okay. So copy from I, subtract from J. If the number is negative. Oh wait, you wait. I'm trying to think of it, you can subtract between two letters. I don't think you can. Can you? I think you can subtract from two letters. Okay, I think never mind. That might work. If it's negative, you do one thing. If it's positive, you do something else. Okay. Have no clue. That would be funny. Yeah. I think you can though. So it's not too bad. Okay, let's see what happens with negative. If it's negative, it means that the number that we're subtracting from is smaller, aka the first number. So I should change that then. JTT, ITT. There we go. If this number minus this number is positive, which means this number is bigger than this number, we want nothing to happen. So what's the I to the J? So if it's negative, we do nothing. But if it's positive, we want to switch numbers. Let's say we copy 2. 19. Well, first of all, we gotta add it back. Add back ITT. Add back JTT actually. Copy to 19. Copy from the position of JTT. Copy to ITT. And then we copy from 19, aka whatever number is specifically here, and then we copy it to JTT. Okay, so that's essentially comparing those two. Once that happens, we want to bump this and then bump this. So then that means we're going to the next two numbers, and then we start over. And to copy from IGT, subtract IGT, yep. And then if we reach a 0 for some reason. Oh, how are we going to do that then? How do we know when we get to 0? But oh well, I was going to test it out. 93, 2. Okay, so the numbers are smaller. What? What was that? What was that whole exchange? Bumps I. Wait, what? Oh, I'm an idiot. You bumped the number, not the index. Duh. Okay. Oh. It switched. Switched numbers. It switched numbers. We're doing something. Okay, but like realistically speaking, we should compare this number with this number. And if these numbers are the same number, then we can say stop. So let's do that. Let's not bump the inbox, so that now becomes a 3. So now that we have that mission done, we need to find a way to compare the numbers. Bump JT if let's see copy from JTT and then subtract from this. If it's 0, we actually move on to part 2, which part 2 is essentially decreasing this. Because at that point, if the biggest number will always be to the highest position at this point, so we just subtract 1, and then we loop it again, back to here. No, back to here. Because we had to start the bubble sort from the beginning. Jump if 0. So if it's ever reached 0, what we want to do is now we can outbox stuff. Copy from the 0 position, and then we outbox. And then we bump up 1 of this. And then we copy from that, and then yada yada yada. Outbox. Copy from if 0. So if it's at 0 at the end, we just go back to the beginning. All the way back to the beginning. And reset everything else. Oh, someone redeem a joke. A man is washing a car with his son. The son asks, "Dad, can't you just use a sponge?" Oh, that's a good one. Okay, what happened? What did I miss? Oh, it compared the last two. What? I thought I stopped it at 3, right? The heck happened? I was laughing at the joke and it broke. Oh no. I was too busy. I was too distracted by the joke. Okay. We'll see what actually happens. All right. 3. Okay, so when it gets to 3, it should compare. If it's 0, where's that code? If it's 0, oh. Oh. Wait, what is this? If it's 0, you want to bump it down by 1, right? And the number is not 0, so therefore it will skip and it'll jump back to the number. Put the 0 there, put the 0 there. Nice. 1. Compare, compare. Stays the same. Compare, compare. Nothing happens. Now it's at 0. Oh, what? So somehow it got bigger. Bump negative inbox is not 0. So it should jump back to the beginning of that loop. Copy from 0. Copy to J, J, right? And then we bump I. We bump J, actually. Okay. Should we have a situation where if this is 1, it stops? But that doesn't really help me much, does it? So those are the same. It bumps J. So if it's a positive number. Oh, there's no if positive, so I can't revert that, huh? Interesting. Okay. So it would never, the index will technically never get to 0 in that case. So I need to find a way here to get it if bump is if okay. I'm gonna do a janky solution, so please bear with me. I'm just gonna put it here. And then I'm gonna bump that into 1. So that box will always be a 1. And then we can do a bump this, subtract from this. If it's 0, then you go here. This is so janky, which I find really funny, but if it works, right? We'll compare the numbers. The numbers will be 1. And then outbox 43? Oh, right. Because that's an index of 1. We want an index of 0. So we actually want to instead copy from, we first must bump negative of this. Okay. I think this works. A really bad code, but it works. In terms of a bubble sorting technique. Why? Why? What? Okay, yeah, box that. Nice. That should become a 1. Oh. There we go. The index wasn't 0, so it outboxed twice. Yeah. I think what happened was I subtracted it. So it's like I added the index, the bump, and I subtracted the bump right afterwards. In that loop in the bottom. You can't add letters. But yeah, anyway, that's what I mean. Like when I bump plus right here, it came at 1, but then it went loop back, it went at 0 because it subtracted that. That's why that worked incorrectly. Okay, what happened here? Okay. Okay. So you can't subtract letters. You just can't add letters, which means I had the right idea from the beginning. Sort of. Let's see. Copy from, copy to, copy. Okay, instead of saying add, add to 19, I probably should have like indexed those two numbers beforehand. So copy from ITT. ITT is a smaller number, so let's copy that to 18. Copy from JTT, the index of JTT, and we want to add it to 19. So this was beforehand. Copy from JTT, copy to ITT. Okay. So this was like the positions that I had earlier, but instead of now positions, I'm just gonna revert back to the original method, which is copy from 18 and copy to JTT. ITT? JTT, ITT? ITT is a smaller number. So I wanted to switch, right? Yeah, ITT is a small number, so I wanted to switch. This way, the numbers actually switch instead of adding, subtracting. Let's hope this works. Holy crap, it's been over an hour? I have been doing this one room for over an hour. That's not a pain at all. Just kidding. It actually is really fun. I didn't realize an hour gone by just from this code alone. But it's pretty fun. Yeah. I'm not adding any letters. I'm just moving them back and forth. Slowly, but steadily. See? No errors. Let's go. Now this is gonna be a pain because it's freaking 10 letters. Dude, watch it. It bugs me out in the last code. It's like, by the way, haha, wrong. You die. Because there's only one number. But yeah, Bubble Sword's the slowest of all the swords, but at least it works. I think prime number is gonna be the pain though. Because the one after this, well, not after this, but like there's the challenge, which is the prime numbers. And I don't know how to do that. I don't even now. I've been thinking about it for a while and I still can't figure out a way to do prime numbers. That's the real challenge, I think. Bubble sort. We're not even halfway through. You look at the index position, we're on number 6, which means it has to go 6 more of those giant loops before you can call it done. Holy crap. Bubble sort. Why are you so complicated? What is the prime number one? So the prime number one is, it gives you a list of numbers, and it wants you to organize the prime numbers in that, the numbers of the prime numbers in that, in a ascending order. So for example, they give you a list of number 15 and then number 17. They want you to output to be 3, 5, 17. What the? Uh-oh. Uh-oh. I think my code is, acting up. Oops. We gotta rewind to see what the heck happened to the 0 and the 5. Oh no. Why is there no rewind button? I don't want to watch 20-minute clip of this guy moving back and forth. Okay. Okay. Reach 0. Nice. Reset. Reset. Okay, that's a 1. Why did I put it at a 1? I don't know. I forgot. Oh yeah, the cheeky 1 minus 1. Okay. 55. Nice. 1. 0. Nice. Zero, 1. Oh, crap. Okay. Blah, blah, blah. Copy from I. Blah, blah, blah. Bump, bump. Let's go through this code. I have a jump of 0 option here for inbox. I think I might want to use that. Which is very, very cheating of me. This is just me writing in a code to get rid of that situation. Jump of 0. Okay. I want to have something here. that says, hey, if the inbox is actually only a one number digit, just go to 0. But at the same time, if I do that, I need to find a way to get the inbox back to 1. So, let's see. Copy from, subtract from. I think that's the only way I can do that. Can't you copy from 12 to the box? Yes, that is exactly what I did. You and I are on the same wavelength. Because there was a 1 right there, I just subtracted it. If it's, so that means that the box is 0, aka 1 minus 1. We should be golden. Now he's got to wait for like 40 minutes to test it out. But yeah, so now while we're waiting, do you guys have any plans for Christmas? It's literally like 2-3 days away. I literally got no plans. My goal is just to relax because I finally have a break after so long. I might start learning how to do some logos because I kind of want to make a logo for myself. A cool logo, not like a lame one. And so I've been watching a lot of logo videos, and man, those are interesting. They make it look super simple for some reason. But like when I try it, it takes me like hours to do something fun. Yeah, there's this guy named Nick. I think he does like logo design tutorials, and like literally he would spend 5 to 10 minutes do like this really cool logo, and then when I try it takes like an hour or more just because I don't know the buttons on the layout, all that stuff. This is the longest one. This is where the pain begins, because if you mess up your code, you have to wait another 12 minutes or like however many minutes this is gonna take to run the code. I think this is a legit 4-minute code from this one section alone. You wanna like you learn a couple hours doing special effects? Transitions? Oh, are you working on transitions? Dude, those are hard. I want to do transitions also, but it's just too much work. I don't have any like good animation programs, and I think it's just going to be extremely hard to make a cool transition. I want to do a thing where it's like a hat pops up and like covers the whole screen, but at the same time the hat is like somewhat hollow. So there's only outline of a hat, essentially. And the hollow part will be the next scene, while the outside the hat will be the old scene. I don't know how to do that yet, though, because I think it's harder than it looks. Are we there yet? Are we there yet? Please tell me we're there. No. 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 We were so close. We were this close to glory. No. Okay, let's see what happens. Okay. Six, 0, 1, 0, 0, 0. Where are you? You are right there. Nice. Right. Copy from index. Subtract. Jump of 0. Okay. Bump inbox. Sub 22. Oops. I don't know if you guys heard the bump, but I'm just like So disappointed. So it's negative. It should jump to here. Okay. Now this should work. I hope this works. I don't want to. This is gonna be a fun 5-minute trip. You put 0, not negative. Uh-oh. What? What? Stop! 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 Did I put 0? Okay, thank you for pointing that out, because that probably would have take another 40 minutes to do. What does this one end up? Okay. Yeah, thank you for pointing that out. That definitely would have killed me for like hours figuring out like why that didn't work logically. Okay. Back to the topic that we're discussing about. So I think from what I saw online though is that the reason why that hat thing is so hard is because there's not a way for OBS to instantly transition from one scene to another at the same time. Or not like at the same time, like you can't have two scenes on the same screen at the same time. So what most people do, the trick is that they have a way to fill a screen completely of the transition in a single or 2 frames, and in that moment the scene switches, which makes it look transition like smooth. At least that's what I've heard. I actually haven't like looked into it myself. But the reason why my hat trick doesn't work is because I want to have like a hat that pops from middle screen and opens up while transitioning. So it's like a wipe. A wipe effect? A star wipe effect? Is that what they call it? But yeah, so like, I don't know. That might be something I want to look forward to discovering one of these days. Oh yeah, excellent. I don't know if you were here when I was like doing stuff, but I have a VTuber now, sort of. This is my Padaru for the Christmas season, of course, because everyone gotta have a Padaru. But yeah, I have a avatar that I don't think I should pull up right now because it'll crash my computer. Because I try not to load anything after the stream has started. Because I've learned that anything I open up after the stream started just burns my computer to the ground. But I'm pretty sure there's like old VODs of me playing with my VTuber. If not, I'll just figure it out next time. We're almost there. We are 7. That means we are halfway there. You mean you're not full-time Padaru? You're right. What am I saying? This is my true skin. I am normally 4 inches short. How tall are Padarus anyway? Realistically, in that chair, I think 2 feet. Like based on the chair size. Padarus are normally 2 feet tall. Do you think so? The only thing for the transition is the shape of the hat you want though, but the idea sounds beautiful on After Effects. Interesting. I guess I might have to look into that then. If it works. That'd be cool. Please. Please. No. Yes. We did it. Okay, let's see how sad they make my code. Okay. Okay, 43 lines out of 34 is not bad. But 1,300 lines of speed? That's pretty bad. Okay, like realistically, that is very bad. But then again, most people don't do bubble sort to solve their problems. They use like insertion shorting or what is the other one? Crap, I already forgot the name. Insertion sorting or the merge sort. That's at least those are nicer. But I am too lazy to do that right now. So with that, we can go to the end, or we can solve for prime factory. I kind of want to solve for prime factory just to get it over with for tonight. And like I said, this is extremely hard because I don't know what to do. Are you sure you're supposed to be here? This is a very difficult assignment. I have no idea how to do it either. Same, bro. Same. Okay. So the goal is for each thing in the prime inbox, send out its prime factors to the outbox in the order from smallest to largest. So let's take a look at the examples. So if they have the inbox of 12 and 7, they want you to have an outbox of 2, 2, 3, 7. Okay, so like, based on this description, it actually doesn't matter. Now that I think about it. Trying to think realistically. The order, like, I guess this 12 is independent from the 7 completely. So that means I don't have to worry about the prime numbers by itself. So that's at least a good thing to know. My idea, the only thing that I can thought of in the last like hour and a half while I was doing the other code is maybe do like put the numbers right here in box 0 and then do a same number in box 1 and then subtract box 1 to 2, see if 3 is divisible by 2, aka by subtracting them over and over until it gets to a negative number or a 0. And if it's a negative number, that means that it's not a factor of this number. So because of that, we can kind of have a list of numbers that are divisible by that number itself. But the thing that kills me is the fact that you have to have 2 2s as the output. Right? So that means you have to first factor out this number into these numbers. And then somehow figure out to factor out those numbers into a whole set of new numbers. And this number is into that. Yeah, so this output will be like 3333. Which is really hard because I don't know how to do duplicates. How do you deal with duplicates, you know? And also, what is the highest number they're going to give me? That's what I want to know too. Is it 24? Is it like some arbitrary super high number that I need to worry about? Do I need to make a list of prime numbers first and then just count it to this? That's a lot of things I need to figure out before I can like jump into this code. Because like realistically, if we have a list of all the prime numbers, even then we still don't know how to like compare them because there's no multiply option. You need to have enough space on the board to have an arbitrary high number. Yeah, that's what I'm thinking. Realistically, like I want these whole bottom row to be like indexing numbers, so I have space to do some stuff if I need to. And then I want like this number to be like the list of prime numbers. And yeah, it has to be in order too. Oh, that's hard. Oh. Yeah, that's a pain. How will we do that? if we put the 9 here, let's say we find a number that is divisible by, aka 3. We also need to know how much it is divisible by, like the count, how much it can be divisible by also. The factor tree. That's what I'm thinking too. Like number, the factors, and then we somehow have to find the primes of the factors. But I don't know. There's enough space for that. Assuming there's like a big number, we don't know. Because we need a space to have all the lists of prime numbers, I think. You know what would be funny? If I take a code from like an old section. Oh yeah, the sorting. We can just take the code from this part and then copy it to the other floor. Copy. Then let's paste it in the other stream. This is a dumb code, so obviously we're not gonna do that, but it's funny. We can paste it here, and look at that. We have our code from the other part. Yeah, let's get rid of that. So we can definitely sort it that way, I think, because we already figured out the sorting algorithm. Yeah. I think it definitely goes a lot higher. Also, I guess it copied the text thing here too. It's interesting. Hey Fino, if you're still watching, do you have any ideas on how to do this? Because I'm drawing a blank on like what is a good way to start this project. Because look at that, this is an 8. You know what the factors of 8 are? 2, 2, and 2. How am I supposed to like have 3 2s on this board? Unless it, like a tree makes sense, but like really, that's a lot of pain coming my way, I think. You know what? I'm gonna start. Copy to that. Copy to that. And then we'll figure it out on the way. So what I want to do is bump this number. Have this number and we subtract it from this number until it gets to 0. If it's 0, then we copy that 1. And we copy it to this box. Let's just split it for now. But if it's negative, it means that that is not a prime factor. So let's move back here, and then we bump 1 again. And we try it all over again. This way, we are guaranteed to have a number factor here. That's what I'm going to do first. Then we got to find a way to deal with these factors by sorting them all out. But for now, this is where I'm going to start. But I don't want to do a copy to 15 because that's kind of jank. Is there a way to get 10? I guess I can add. That might be a better option. Copy from 0, copy to 20, let's say. And then I want to bump 20 bump 20, add 20, copy 220. So that's a 4. I'm just gonna bump 3 times actually. So that saves me like 5. So let's, okay, this goes to 10. But I want to copy it to 15, so I actually should add another 10, 5. So now that's 15, so copy to whatever the index of this position is. And then bump 1 of this. And then we go back to the inbox. No, not the inbox. What is this? Is this after we found a number? Yeah. So we also want to go back to this, right? So bump 1 if that is 1. If that is 0, then we jump here. This is just a test for now, but should just be 10 after this. 15, nice. Grab 3. Place in 3. Place in 3. Subtract. That's not. Oh no. Is that an infinite loop? That's an infinite loop. Oops. What I meant to say is that this is so hard to do mentally. I don't know how you're doing this. No clue. I am just testing stuff on the go, and if it's working, it works. If it doesn't, it doesn't. Yeah, like how do you do with the prime numbers that are already prime? You don't. You just keep looping through. Oh no. Oh no. Oh wait, no, it actually does work. No, that's legit. Why did I say oh no? I think that was what I intended. It should be a negative number, so you know that's 6, 7's not a prime. We know that 5's not a prime. We know 4 is a prime. Whoa, whoa, whoa. Why did it put 0? It should have... Oh, right. If 0... I want to add that number back first. And then copy 2, and then we bump to that. And then we jump back to what this was, and we, yeah. So essentially what I was doing is I want to have the prime numbers, or not prime numbers, but like numbers are divisible by 0 listed here. And then I gotta determine if they're prime numbers after I get all the numbers that it is divisible by. So for example, you see that number was a negative, which means that it is not divisible by 11. Well, the 11 by 10 is not a whole number. So now we're just testing all the numbers between 11 and 0 to see if they are whole numbers. And obviously none of the numbers are going to be a whole number besides 1. So when it gets to 1, I just want to see what happens if it gets to 0. 1. It's obviously a negative number. So therefore it doesn't work. So let's move to 3. Move to 2. And then moves to 1. And then I want to see what's happening when it gets to 1. Well, obviously if it gets to 1, it's gonna go to a 0. And it was gonna go to whatever I put here. There we go. Yep, that's what I thought. So, if it's 0, you jump to the end. So what this happens is that it essentially iterates through all the numbers, and it output all the numbers that it is divisible by. So now the question is, the main question is, how the heck do we figure out which one of those numbers are prime? Unless we have to like physically go and redo each one of these numbers to make sure that they are prime. But that's, I don't know. Well, first thing first, I also gotta realize, copy from that, copy to whatever the index of this is there, because we also gotta account for the number, the big number itself, right? We can't just ignore it. So now this case, I believe, if I'm correct, it would have been a 1 and a prime number there. Let's have a 1 here. I need a 1 just to compare it, because like later I want to see like if this is a 1, subtract from this, it's a 0. We can use the if 0 and skip that number. That's what that 0 that's what that 1 there is for. Realistically speaking, the numbers are going to be sorted from highest to lowest, I think. So, first thing first, let's get rid of this add 20. So it starts at 10. Inbox, copy to, copy to. Oh wait, do I want to copy to that? I don't. I do not. Never mind. I did want to add that 20. No, I don't. No, I don't. Let's just keep it at 10 for now. So we have 10 spaces to work with. Let's move this bump. Where does this go? I wanna bump this later. You know what I mean? Because I want to have the number in the beginning too, in case it actually does subtract it into itself. Because I'm trying to figure out how do we get that prime number in. There's also an issue with putting number prime factor into the at the end. Yeah, that's what I was thinking. We do with bubble sort. Yeah. No, I'm trying to figure out, like, let's say it's an 8. I don't want to put an 8 in this list down here. Or do I? If I put 8 down here, it's just going to be a recursive situation, I think, if I were to do that. So, okay, I think this is fine for now. This is tough. Hmm. Like, I can get the numbers that is divisible by, but how do I get it to tell if it's a prime number or not? That's what I'm... Okay. What if, let's say we start at 10. We found all the factors of this number. Let's say it's 8. So is this going to result of 4 and then a 2? Right? So it's a 4 and a 2, and we put that 4 back in. It's just going to find 2. The solution of, is it 2 and a 1? But then there's... Oh, how does it know there's a double? I think the double is what's killing me. How can you tell if it's a double number that's being multiplied? Because, like, I can... Like, I separated it out, like, a 4 and a 2. That's easy. But then how do I get to separate the 4 into a 2 and a 2? That's the tough part. Because if it's a 15, it would be like a 5 and a 3. And it'd be like, oh, we're done. We can just put those 2 numbers in. I'm not looking at the sorting part, but I'm just looking at the squared part. That's the pain of this question. Yeah, exactly. It would be a 1, 2, 4. Oh, I mean, this guy did say it was impossible. This is a very difficult assignment. I have no idea how to do it either. This guy already gave up. He's been here longer than I have. Look at his hair. It's like non-existent. And my hair is about the same. I say if I can't figure out in the next 5 minutes, I want to go see the ending clip. And then we'll pick it up another time because I have no clue what to do. Maybe like my subconscious can figure it out. That's what I'm hoping on. It's possible. Yeah, it's definitely possible. I'm pretty sure there are solutions online that optimizes like to the itty bitty speed challenge and stuff like that too. So I don't doubt it. The question is, can we figure it out? Maybe I can write stuff down. That would be nice. I actually had a thing where I opened. I was gonna use Krita and like share it on screen to see what my thought process is. But then I didn't test it out, and earlier I broke Phenotype's ears because it was playing loud noises when I did that. So that's the backup plan for next time. But for now, this is only mental game. uh, What is a good solution to... Maybe I can do like a counter. Have a counter that says if the number is not divisible by 3, or like if the number is equal to 3, it means that it's a square in there somewhere. Because perfect square only happens, what, twice or once? Right? Can you think of a number that has 3 multipliers that are not squared, or 5 multipliers that are not squared, that are squared? Okay, let's have this as 3. Copy 2, 3. Okay. Oh, not 17. Good thing I wrote the letters. That's 3. So I can also do a count situation where if I can put the numbers in here, copy 2, bump 20. I can also bump this number here. And if it's somehow magically 3, let's say do this. There's number of factor. So based on this, after this is after I solve all the factors, I can compare this number, copy from, subtract from 3. If it's 0, it does something. And that something is essentially, I need to multiply the 2 middle numbers again. But how do you know which one's the middle number? Yeah, we're gonna need like a piece of paper or something for this, I feel like. Because I need to figure out the optimal like positions of squares I'm gonna use for each section. Like for example, these 2 would be used for subtracting. These 2 would be used for the first factor. Am I using these spots for like the next few positions? I don't know. Like realistically speaking, that might be a good question to ask. Like would this be for the first factors? Would these for the second factors, and would these be like for the third factors? And then I somehow supposed to compare them individually. I don't know. Yeah, I think it's for now. I'm just gonna pause this. I'll figure it out later. The thing about 16 is that if you look at 16, the factors will be, oh crap. You're right, then my code wouldn't work because it'll be 8, 4, 2, 1. And that's not, yeah, no, that's just bad. No, okay, so my idea is trashed. Yeah, that 16 kind of ruined it. You're right. I think that's a good thing to notice. So yeah, that whole strategy, I think it's gonna work. I'll have to think of something else in the meantime. But since we did solve 41, let's check out the ending. You don't want spoilers, don't look. But essentially, what happens at every 10 floors or however many floors, there's like a story mode. There's like just like a quick animation that just about random stuff. I can show one of the older previous ones, and then actually, I'm just gonna say you've been warned if you don't want spoilers for this game. You have been warned.
Congratulations. You've really become an invaluable instruction follower.
Yes, don't worry, your job is safe. We've replaced you with this electric box.
It's called a computer. It iterates through a list of simple instructions, called a program.
It has a small amount of memory to store data while processing, like tiles on the floor,
It has inputs.
and outputs.
It simple instructions can be used together in infinite combinations to compute just about anything you can imagine.
A truly efficient worker that never sleeps.
It's going to change everything.
Please take your things and enjoy whatever it is you people do out there. Congratulations.
Wait, so did I just get fired? That's not weird at all. What? I guess here's the weird part. We have been overtaken by the robot overlords because we did such a good job at sorting numbers. Why does my character look so happy? He just got fired. Why is he so happy? He spent 41 years of his life, aka 41 levels of his life working at this company, and then they fired him and he's like, you know what? I'm just gonna walk to the right. That's so sad. GG's. Wait, is Boss Lady? Did I see that right? I thought that was a guy with a goatee. Wait, what? Did someone else see Boss Lady as the name? Wouldn't he be 59? I guess so, yeah. He's an old man. He's ready to retire, I guess. Yeah, 40. It just says 42 years. I kind of assume. Let me go back to level 1. Was he a baby? I can't remember. Nope, he's a bright young lad. Yeah, you're right. I'm pretty sure it's like 18 to 20, so he's at a retirement age, I guess. It's kind of sad if you think about it. Yeah, every year is essentially like every level is like a year of your age. Oh yeah, this one was a weird one. We can watch these clips.
Hey, where's Carol?
That's Carol.
Oh my God. This coffee is amazing. Back to work, ladies.
Breaking. Previous reports of machine army evaluate to false. Everything equals 100% fine. Whether within pleasant tolerance parameters or human skin layer, you're all going to be fine.
Yeah, that's not ominous at all. When I watched that first time, I was like, holy crap, she just fell off the floor. And then apparently no one cares. But yeah, all these clips are pretty fun. I think it's worth to watch if you haven't watched them already. Employee morale insertion. Some of these are funny, yeah. But yeah, this is the long journey that we've been through. We were able to solve 40 puzzles. Technically 41 puzzles because this counts as a level. We just need to figure out the prime factors next time. But I did spend like 2 hours. 1.5 of them was just on this part. Which tells you how hard these levels get. But for now, I think I'm gonna pause this game here. For now. And then I'll think about it. If I think I have a solution, I'll probably put the stream back on and try to go for it. But for now, I can't think of a good solution that can fit in the area that it needs me to. But yeah, if I can't figure out a solution, I'll probably just move on to the next game. There's a sequel to this game called 7 Billion Humans, which is essentially controlling many humans together. I could just show a quick demo real quick. I don't think it's a big deal. Would you like to play touch controls or Joy-Cons? The worst part is there's no Pro Controller. Okay, thank you. Yeah, there's a sequel to this game. Isn't that cool? Instead of one person, you're controlling 7 billion humans. We can definitely watch the trailer. I think the trailer is fun to watch. So I actually started it. I wonder if it let me show you the clip in the beginning. Yeah, it does. Okay, so we should watch this one. It's actually pretty funny. Well, not funny, but like these kind of humor. Ready? Watch.
Hey, you! Are you a hard-working farmer? Let machines do that for you. Are you a hard-working coal miner, truck driver, or coffee shop employee? Let machines do that for you.
Well, actually...
Tastes like progress.
But aren't there any good jobs left for hardworking families like us?
You'll never need to work again. Machines have provided unlimited free energy, unlimited fast, clean transportation, unlimited free nutritious food. You're completely free to do whatever you want. A marvelous modern utopia.
But we want good-paying jobs!
Okay, creating jobs.
You want jobs? You will have jobs. They will be the best jobs. Huge. Believe me, you have never seen so many jobs.
Where do we get these jobs?
Just show up on Monday. The machines have created enough jobs for every single person on the planet and the whole family to enjoy.
I have a PhD in medieval French literature.
Even the most useless skills can be put to work in the new office building visible from space. Congratulations, all 7 billion humans on the planet. You're hired.
But yeah, that's the intro. Honestly, it's one of my favorite intros into any games for a long time, just because of all the references and it made. And it's just like dissing on so many people at the same time. It's just it's a glorious trailer. It's an amazing trailer. I would just get the game just for that trailer alone, just because of how funny that was. Yeah, it's hilarious. The game itself is just that trailer alone. But yeah, so the cool thing about this game is that there's a lot more levels. And there's just a lot more complicated stuff because you're not controlling one person anymore. You're controlling a multitude of people. Which I've only gone to like the first 4 floors. But overall it looked pretty fun. I'm definitely trying this game out next after I've solved the prime digit. Or I can just start this game realistically. But yeah. Let's just do the first 4 levels because I already did it. I can just talk about what happened in these levels while we're here. Yeah, as you can see, you control multiple people. You have a certain rules. Step is essentially you move the character. So you've actually had to physically move your characters now in this game instead of like the other game where it just controls based on input and output. This one you control the person, so you have to move them down. You pick up the box. And then you drop the box because that's what they wanted to do. And as you can see, like there's many things. It's showing case what everyone's gonna be doing. Yay! Yeah, this is a lot harder, I think, from what I can see. Command tell your workers to move line all the way down by 2 tiles so it sits between the potted plants. So yeah, pick up. move down 2, then drop. The cool thing about this game is that they literally teach you the basics so that you can have an idea of what to do. Long distance delivery. Clear the room. All the workers in a cube must fall into the infinite pit. AKA, we must kill the humans. New command, jump. Use this command to jump to a different line in your list of commands. AKA, you know, the loop that we've been doing earlier. You might use this to repeat a selected section. Yada yada yada. Yeah, we go left, we pick up the box, and we move all the way to the end and watch the people die. And that's that level. Yeah, this game gets dark. It's technically because, you know, humans taking over the world kind of thing. I think that's the premise of this game. But yeah, that's the first 4 levels that I've been through. I actually haven't done anything else, but we can just let's go to the coffee thing and then we'll stop. I think that'll be a good stopping point for today. Let's go for it. I have not read this part yet, so we'll figure it out together. Let's go ask ourselves a little question. Would you prefer an instant shrieking splattering doom? Or going to a really fun office birthday party? Oh no. One side, you have a nice data cube illuminating the way towards the office party. On the other side, you have eternal doom. Use your new if command to locate which side has a data cube. And continue walking that direction until you fall in a nice hole that will take you to the office party. But like, at the same time, isn't that also death? If blank equals a data cube, step that way. Otherwise, step that way. And I think we need to loop that step. Do we need to pick up the box though? That's the question. That's what I want to know. Oh, I don't want to go down. Why would you want to go down? That's dead. Okay. So if anything on the left side, anything on the right side is a data cube, aka this person and this person, they will go to the right. And if not, they'll go to the left. That seems good. There we go. Yes, congratulations. That was truly a magnificent feat of engineering. Yeah, you know, I don't have to pick it up. I was just worried like you had to loop it or not. That guy's fun. Pluto Exterminator 1, Year 6. Oh no. I'm learning programming. In fact, I've already saw the assignment for you. Well, sorta. The worker is supposed to pick up the cube from down below without falling in the holes, but something's wrong. So I'll allow you to fix it for me. Let's watch what happens together. No. Are they gonna kill her? They just killed her. Oh no. Rest in peace. You will be missed. You will be missed. Let's see. Tip, you'll need to change or add only one single command. But if you're welcome, you can use more if you like. So step down, step right, step right, step down, step left. If blank equals nothing, wait, what? If blank equals nothing? where you edit the program. You just about to step through. Oh, it makes you actually go through the slides. Okay. I mean, that's good. It teaches you the mechanic of like going through the options. If blank is nothing, you jump. Okay. Okay. I'd rather not kill her, but I guess the game is making me do it. Else. Step back. This is such hard coding, by the way. I don't know how I feel about this. But hey, we made it. We saved that girl from keep falling into her death over and over. This place is a mess. The engineers left data all over the floor. These people have no appreciation for style or something. Okay, let's pick up all the data and organize them into night bottom row. Right between the use Pharaoh. But watch out for that infinite hole. What? How can you know where the data cubes are or where you find them? Well, just say if. Yeah. Ooh, there's a squiggly line. We can do code now? We can do the comments. Yeah, we can do the comments. Nice. Okay. Jump. Pick up. If down equals a data cube, you want to pick up that data cube. Oh, you can pick up the data cube from like below you or above you too. Wow. Okay, organize the data cube into a line along the bottom row between the two arrows. So you don't want them to fall in. Got it. Step. Down. If bottom's the data cube, you go pick up the bottom. If the bottom is a hole, then you want to drop the box because the bottom, which means you have to be right here, and then you just jump out of the way and end the code. I think this works. These people will pick up the box, otherwise they'll keep walking. Nice, they're all together. They're all together. The hole there, so they're just gonna drop it, and they're done. Let's go. We saved 7 people's lives today. Really, on the edge. Ha 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 ha. That's funny. Not really. Okay, so before we do that though, I actually want to see what happens individually. Ooh, you can see the individual people too. Okay, that's actually really cool because now you can see like what person's doing what. So they pick up the future, but they still stay in the same spot that they did. That's good to know because in the future, if I need to like figure out if they're moving or not, then we can just figure it out if they're gonna fall into the death pit or not, kind of thing. So like as you can see, those people right there, they moved ahead, but some people were picking up the box, so they were staying behind. You can kind of see like what everyone's kind of be doing at all times. Yeah, that's kind of cool. I like that. There we go. Whoa, now we're living dangerously. Okay. Well, like I promised, we have made it into the moral intro to the moral officer. Let's watch what happens.
Congratulations, you're doing great.
I cannot believe how great you're doing.
As your employee morale officers,
we are here to offer occasional tips on how to keep your workers feeling delighted.
For example,
come on up, Jeff.
We find that workers appreciate an occasional confirmation of a job well done.
You might say, congratulations, You're doing great.
Followed by a gentle but firm pat on the rear.
That a boy, Jeff.
When I was his age, I was a refrigerator.
Good work, everyone.
You know how many salads will fit inside me?
With enough teamwork and engineering, even a kitchen appliance can become a mid-level office manager.
We're not just building data solutions.
We're building a family.
Oh, that's so bad. Did you see his face when they're like, yeah, you can hit them in the rear? And he's like, what? Huh? I'm gonna watch that again. That's actually pretty funny.
Congratulations. You're doing great.
I cannot believe how great you're doing.
As your employee morale officers,
We are here to offer occasional tips on how to keep your workers feeling delighted.
for example,
Come on up, Jeff.
we find that workers appreciate an occasional confirmation of a job well done,
You might say, congratulations.
Okay, but seriously though, why am I
You're
already
doing
bald?
great.
followed by a gentle but firm pat on the rear.
I'm only 9 years in.
That avoid Jeff.
When I was his age, I was a refrigerator.
Good work, everyone.
You know how many salads will fit inside me?
With enough teamwork and engineering, even a kitchen appliance can become a mid-level office manager.
We're not just building data solutions.
Uh,
We're
Building
building
a family.
Okay, that was good. I enjoyed that. Okay. But yeah, that is all for now. I think this is a good stopping point. Next time we might go on further into the next stopping point. Holy crap, that's actually a lot of levels between the stopping points. But hey, that's something to look forward to at least. Oh, that's gonna be fun. That looks like fun. Oh, some people can talk to each other in phase 3. You can throw out arrows in phase 4. The heck? Oh yeah, okay. I guess that's something to look forward to next time. But for now, thank you all for coming by. Thank you XN5 for coming by. I haven't seen you in a while, so that was pretty fun. And thank you Fino for coming by also. But yeah, that's all for me today. Hopefully I'll see you guys next time when I stream this again. Have a great day and happy holidays to everybody. I should get an outro screen. I have an intro screen, but I don't have an outro screen. So I was going to put the intro screen as my outro screen for now. But I'll see you guys next time.